Hi guys, thank you for joining. I hope you have a good presentation so far.
Hi, let me introduce you, Danny. So this is Danny. This is our new talk, and welcome Danny Voicu. He's a security director in Bigfinit. It's a technology startup for pharma and biotech industries, and he's very passionate about cloud security and how companies can adopt and use cloud services securely, especially focus on AWS. So welcome to our Stay at Home conference, and thank you for being here, Danny.
Thank you, Goy. Appreciate it, and thank you for the organizers. You guys did an amazing thing here. So I know staying at home is not as great, but I must say I enjoy not having to iron my stuff. So all good. So we're going to talk about cloud security, focus on AWS. It's a 30-minute presentation, so we're not going to have time to do a lot, but we're going to do the best we can with the allocated time. So Koeb already presented me. I'm a VP of security at Bigfinit. It's a technology startup that's building a cloud serverless platform that helps pharma and biotech companies deal with their manufacturing data, things like collection, visualization. It's all in the cloud or serverless. If that sounds interesting to you, we're also hiring in Barcelona. All right. So the first thing people ask me when I told them what I do is cloud more secure than on-prem, right? It's a common question. And the answer is yes, if you know what you're doing. Since in the cloud you have all the infrastructure managed as a code, or it can be managed as a code, it's so much easier to audit, to enforce rules, to correct problems. So that's the true benefit of going cloud. On the downside, though, cloud services are relatively new. So talent out there, especially on the security, is scarce. And then many components or services in the cloud are, internet-facing by default, public cloud by default. So it's easy to mess it up. And one setting, one mistake can spell doom for your day, your project, or your company. And we're going to see some examples of that. So let's start with talking about some anti-patterns. An anti-pattern is something you wouldn't want to do. It's a carryover technology from some older days, something that you probably don't want to do in cloud unless there is a legitimate reason for your particular infrastructure or for your particular application. So virtual appliances, right? So ever since people started moving to cloud, the traditional vendors like the likes of Cisco, Palo Alto, that would make these expensive firewalls and load balancers and stuff, try to sell you the concept that you need a virtual appliance. So you need a VM in your cloud that will see all your traffic, and then you're going to do some smart processing there. Most of that is BS. You don't need those. Actually, using virtual appliances is probably going to harm you, because what you're doing is you bring all that baggage, all that noise from on-prem into the cloud, and you cannot manage these virtual appliances from the AWS console. Probably it will be hard for you to manage them as a code. So you're complicating your life, and then you're complicating your infrastructure. Since most of the traffic would have to pass through there, you need to care about resiliency. So my recommendation to you is try to use as much as possible the cloud-native services. Right? So the security groups in AWS, they cannot fail. They're embedded in the fabric of the AWS infrastructure. So try to use as much as possible cloud-native services. If you do need more advanced things on the security or operational side, try to use those in the OS as agents, maybe on your servers if you use servers, or as content delivery network. You might want to have the WAF from Akamai, for example, which is probably superior to the AWS one. So use cloud native services as much as possible where you can. Tunnel to company network. Likewise, you should use public cloud. You should have everything done in your cloud accounts, and you should serve your customers directly using the cloud internet gateway. So another one that I see a lot, everything in one account, right? So people think of an AWS account like your data center. So you move everything in your data center into one account and you have it. So that is not a good pattern, because you're going to put so much stuff in that account that in case there is a breach or you're going to have an operational issue in that account, everything breaks down or all your data is compromised. And you don't want that. So what you would want to do is consider accounts as something that is maybe disposable, something that you use as much as you need to, and then you create others or you delete others. You might want to have one account per project, one account for each customer. You might want to have various internal accounts for your DevOps and so on. So experiment with this, because it's so much worth it. This is the power of the cloud. Independent accounts, this would, assuming you choose to have multiple accounts. Now, if these accounts are independent and they're not inside an organization, you're going to have an issue applying governance to those. So use organization, bring all your accounts within one or more organizations, and then have the accountability and the governance applied at the organization level. IP-based authentication, we're talking only IP-based authentication. I'm seeing this happening a lot, and it's a really bad pattern. So you would want to have identity-based authentication to your services in your application. And if you want to add on top of that IP-based restrictions, that's also fine. But identity-based authentication is a must. And then self-managed EC2 instances. This might be the more controversial statement, but as much as you can, try not to manage VMs, right? To manage operating systems, because operating systems are a big attack vector, and there's nothing you can do about it. You depend on your Microsoft or whoever owns your OS to deploy the patches. So it's a big security gap. If you can avoid it, go with serverless infrastructure. Don't spend time managing OS. Now, if you do have managed VMs, then try to get immutable infrastructure out there so that you can kill those VMs and create new ones based on new image with all the patches. Don't try to spend time connecting to servers and trying to reconfigure them and patch them. So where to start? Sadly, the most complicated process or system is the one that you need to start with first, the access permissions, identity and access permissions. And so you would want to ensure that you have multi-factor authentication everywhere. A lot of people actually miss this and with disastrous results. So you would want to have a multi-factor authentication everywhere, including the root account. And then another best practice here is to force all your users to do assume role, right? So assume role will mean that when users connect to your accounts, they only have minimum permissions, maybe to manage their password, to create their MFA, that sort of thing. And then they will have to do an assume role. So, and when you do assume role, you can put conditions, where the user is coming from, whether it has multi-factor authentication, even IP address restrictions. You want to use that because it gives you so much power over how your users can connect to your infrastructure, and then what conditions you might want to enforce users on to assume particular role. So you might have different conditions for assuming an admin role versus a developer role. And then finally, something that is a bit masochistic, because it's going to be a forever activity, you'd have to monitor your unused IAM objects and delete or disable them. So I like to delete everything that is unused for more than 90 days in IAM, whether it's users, keys, passwords, roles, policies. This is a good practice. Play with it. AWS offers you a great wealth of tools to do this. There's a credential report. There's an access advisor. There's various reports and tables that you can use in the IAM portal. I recommend you to experiment with those and decide what works for you. Still on the IAM and access policies, you would want to restrict admin access, obviously, but you also want to ensure that you control the shadow admin. So in the links here, you're going to have a more extensive description of what a shadow admin is, but it's basically a user that, knowingly or not, has more privileges that they're supposed to, and they can assume through some steps admin or near admin permissions, right? So once you get familiar with this, and there is an open source tool that can check those for your account, once you get familiarized with those commands, what you can do is on the roles that are non-admin, you can start applying explicit denies for those privilege escalation commands. So I encourage you to explore this. And then, the thing that most people fail at, because it's hard and it's continuous, is to enforce last privilege and need to know principles. Don't get too frustrated. If you don't get this done, nobody does in reality, but try to get it as best as you can and try to continuously improve. Okay, and in addition to IAM level controls, in AWS, you have various other service-specific access policies. It might be under the snapshot, the DB configuration, whether Elasticsearch is in VPC or not, that sort of settings. So you definitely want to keep an eye on these and have them controlled, especially since many of these services are databases and they contain a lot of data. I recommend you to start with AWS config. It has a wealth of predefined compliance rules. You can build your own if those don't work for you or you need additional, and you have the link there to get you started. Another great tool, service control policies that you can apply at the organization level. You can apply it for the entire organization, for some accounts, for a group of accounts. Service control policies are very powerful. They can block certain activities that you don't want them being performed on your accounts. And not even the root users of those individual accounts can bypass the service control policies. So they're really powerful. Things that you might want to enforce with this. Deletion of data. You might have customer accounts where you don't want data to be deleted ever, right? Organization leave. You don't want somebody to try to sneak up an account out of your organization. Changes in regions that you typically operate in to limit, any sort of kind of gray infrastructure in your cloud accounts. Disablement of security controls. Anything that should never be done, you can put under a service control policy with an explicit deny, and nobody would be able to bypass them. The other one that you must absolutely use is the S3 block public access. So a lot of the data breaches that people experience in the cloud, particularly in AWS, but not exclusively, comes from insecure S3 buckets and storage accounts. So S3 buckets being made public incorrectly or by mistake is a big issue. And in the past, it was actually really hard to figure out if that happened to you. You might have thousands of buckets. You might have to do kind of API intensive calls to figure it out. AWS changed that, and now you have per account a global setting that you can block all the buckets in the account from being public, and this overrides the actual S3 bucket configuration. So it's a one-stop shop where you can enforce this. Now, I do caution you that the last item in this list, the fourth configuration, you might want to keep disabled in case you have S3 data access between your accounts. So give it a look, but probably the first three you should always have on. Now, if you do have a public website hosting in S3 or some S3 buckets that have to be public, I recommend you to create a dedicated AWS account for those. Don't disable this for your account because you're putting yourself in danger. Just create another account for those S3 buckets that have to be public, and don't do anything in the other in that account. Just use it for this purpose. So you should also be careful with the AWS Managed Policies. Typically, AWS does a great job at doing a good balance between usability and security, but they failed spectacularly, in my opinion, with this policy on the screen for Amazon System Manager, which is a sort of VM management that you can use from AWS. But if you assign your VM this role, the VM and whoever has access to it will receive access to all the S3 buckets in your account, which that's an insanely amount of privileges for whatever this system was supposed to do, which is manage your VM. So be careful with both your policies, but also which AWS managed policies you're using. Other services that you want to enable for security, obviously, global CloudTrail. Don't create more than one because only the first one is free. That will check the unusual behavior in your account. AWS config, we talked about it. It gives you compliance rules, dashboards. It has cross-account collection. AWS Inspector. So unless you already have for your servers vulnerability management and configuration compliance tool, this is a nice one to use, and it's pretty lightweight. GuardDuty, which is a basic IDS, which I recommend you to use if you already have, for example, some accounts. You might not know what's going on there. Putting GuardDuty on it's almost guaranteed it will show you some problems. Maybe some of your VMs are doing Bitcoin mining. Some of them are communicating with shady domains, or some sort of weird, behavior is going on with your CloudTrail activities. And then finally, Security Hub, which is a sort of poor man's SIEM. You can aggregate here a bunch of data from AWS and some from the third parties, and it kind of gets you up to speed if you don't have a full-fledged SIEM with information and data from the various services. The problem that I see with both GuardDuty and Security Hub is that although they can aggregate between accounts, they can only do so per region. So you won't have all your GuardDuty events for your asset. You would have all your GuardDuty events or Security Hub findings per region, which is kind of annoying because you do want cross-region correlation as well. All right. So what do people typically screw up in the cloud? So I got 3 use cases of companies or organizations that screwed up pretty badly, right? So let's start with the first one. Capital One is a US bank. You might be aware of this. They leaked the banking details for about 100 million Americans, which was pretty bad. And we have various pieces of information on how this happened, but basically it goes like this. They had a VM with a WAF product, which was vulnerable, right? And then the attacker was able to log into this VM, and the VM had permissions to all the S3 buckets in that account, and the attacker just copied all the data. So that's kind of stunning from a bank that, one, hey, you're using OSs that are unpatched. What's wrong with you? You should not use OSs, or you should patch them, but you should not have that, right? Then this WAF VM had permissions for all the S3 buckets in your account. That's clearly a lack of due diligence on list privilege and need to know. Why would a WAF need access to all the S3 buckets in an account, right? So this kind of can show you how the link of having an old OS or a vulnerable server plus bad permissions can get you in trouble. And then you can talk here about whether there should have been more segmentation. Why were the details for all the accounts under the same account? Why all the user or personal information was on the same account, and so on and so forth. The second scenario is with open S3 buckets. So this happened with a lot of companies, but this is now easier to fix with that global setting that allows you to control the behavior of your buckets. And then finally, this is a really sad story. So CodeSpaces was a startup that was offering services for cloud for companies that wanted to start using AWS Cloud. And what happened is somehow they leaked some AWS credentials, and the attackers took over their AWS account and they asked for a ransom. They were thinking, we're not going to pay for ransom. We're just going to block the attacker's access. But the attacker probably was monitoring the account. So when these guys were trying to limit the access and force the attackers out, the attackers deleted all the data in the account. And then the company went out of business. So this one, we talked about it in the previous slides. First, use multi-factor authentication. It will save you from this sort of problems. Second, why deleting an account gets you out of business? You should have multiple accounts. You should have backups in different accounts. So they didn't have a disaster recovery situation. So as a result, they went out of business. Some honorary mentions here. Trusted advisor. It's like a security report. If you just start with an existing infrastructure, have a look at this first, because it will tell you some glaring problems that you might want to fix. And then encryption at rest, right? So many services in AWS support it, and you should use it by default, right? You should use it everywhere it's possible. But be mindful that encryption at rest is not helping you in many scenarios where an attacker would leverage some permissions. And those permissions typically have access to both the service, but also to the keys to decrypt data to that service. So definitely no reasons not to use it. It's required by a bunch of certifications and probably your clients, but don't use it as your main security control either, because you're gonna be in trouble if that's your only control. All right, so we got to our Q&A session. Hopefully you guys have some questions for me.
So thank you very much, Daniel. Yes, I mean, we have, well, I really love the talk. I think security is more important every day. And we have some questions here. First of all, how abstracted you think that security should be from developers?
Yeah, that's a very good question. So obviously, right now you cannot separate security from the developing lifecycle. So you should train your developers to be mindful of the security items. You should give them the right tool, and it shouldn't be that security comes from outside, right? You should embed security at every step, and you should work with the developers to be your best allies in enforcing security on the entire development cycle.
I think it's kind of related. The question is, how do you think is the best way to split infrastructure in multiple accounts? And should each independent project to have its own account?
Yeah, that's a good question as well. It depends on the type of infrastructure you have, the type of platform, how you're developing code, and so on. But what I would say is try to be as spread out as possible, but still be able to manage it properly with your operational tools. So that's where you're probably going to see you would want to spread out, and at some point your operational teams, your DevOps, your tools will start showing some issues, and then that's probably your limit, and then you might want to contract it a bit, and that's your hotspot there.
So another question is like, how will you protect your security related services like Inspector and all the ones you explained to avoid users that they can access the data or they can modify logs or traces?
Yeah, that's a great question as well. So first, you would want to use service control policies so that once you configure these, nobody can change anything, right? And that you can do that with service control policies. So you've enabled it, you created a new account, you added to organization, you enable everything, you apply service control policies, those won't change anymore. And then what you want to do, as soon as data is emanated from these services, you grab it and you send it to a dedicated security account that only very few people have access to. And then in that account, you basically aggregate it, correlate it, and so on. So you should never have, or in only some specific cases, you would have to go back to your original account to get some critical data for your security processes. You would do everything in your security account, and nobody from the original account can mess up, compromise your data in the security account.
So another question says, should security be also PM or PO, like I guess it's project manager or project owner responsibility, and how do you achieve that?
So first, I think the dynamic of security has to change a bit in the companies, in all the companies. In that is, security should be responsibility, and actually number one responsibility of everyone in the company. And then the security team is your ally in accomplishing this, versus a policeman that will come and tell you that you've done something wrong. And this comes with training, comes with making sure that security is in the KPIs of all the teams, including development team, project management team. Your VP of engineering should have some security KPIs, and the senior management as well.
I think we still have a couple of minutes, so I have another question that they are growing, and it's like, what if multiple AWS accounts share data using S3? So you mentioned to disable the cross-account access, and then a bad practice. Is that a bad practice to do?
No. So sharing S3 buckets is a current practice. And in actually, for example, for your security account, you might want to do just that. You might want to send all the data that you emanate from an account for security reasons to an S3 bucket in your security account. So in that scenario, you just disable that one thing that says block, cross-account access on your S3 bucket settings, but you leave the other on, which means that you ensure your buckets won't become public.
Okay. And we have a couple of questions asking you about if your slides will be online, and also if you can recommend a book or a resource where people can learn about security systems.
Okay, so what I can do, I can put them on, I will try to put them on LinkedIn. So you guys can hit me on LinkedIn. I'm pretty active on that. And I will also try to put as much as possible
you can hand to the staff the links, and maybe we can put them in the YouTube chat if it's okay for you.
Perfect. Yes, absolutely.
So thank you very much, Daniel. Really, really nice talk. And we are gonna come back in a few minutes. Next talk, we want to just say an advice. Next talk is gonna be in Spanish, and then we are gonna have a break for lunch. So sorry for the English speakers. But we also wanted to have a few speakers Spanish, since we are doing this from Barcelona, but also around the world. So Thank you very much. We are back in a few minutes.
Guys.